Okay, good morning, students. Today we will discuss another topic of VLSI system design. In previous class, we discussed about the first topic of our VLSI system design, VLSI CMOS subsystem design. That is VLSI system design. That is basic theory of CMOS along with some data path operators. This topic we covered in our previous lecture. Now in this lecture we will discuss the second topic. Now in this lecture we will discuss the second topic of this unit, that is parity generator, circuit. So before starting this topic, first we have to understand what is the mean of parity generator. We can easily understand this topic by using this theoretical portion. That parity generator is a sequential circuit. Parity generator is a combinational circuit that is used to check the parity that is transmitted from the transmitter end. Okay, now what is the parity? What is the mean of parity? Parity is nothing but some extra bit. Parity is nothing but some extra bit. Okay, parity is nothing parity is nothing but some extra bit. Parity is nothing but some extra bit that is attached with the message signal, and transmitted towards the receiver. When receiver getting the data stream, so at that time, first he check the parity bit, and accordingly it knows the condition of message, that it is that the number of one in the data is even in the even number, or it is in the odd number. Okay, so first we see the theory of parity generator. Parity generator is a very useful tool in the information processing in the digital computer to indicate any presence of error in the bit information. We already did discuss this topic. It is mainly used to represent the even and odd condition of data to the receiver. Okay, second point is that external noise and loss of signal strength second point is that external noise and loss of signal strength causes loss of data bit information while transporting data from one device to other device locating inside the computer or externally. Okay, this one is the second point. The third point is that to indicate any error, an extra bit is included with the message according to the total number of ones in the set of data, which is called parity. We already discussed this term. Parity is nothing but some extra bit that is attached with the message signal, to represent the some necessary information to the receiver side. Parity is of two types. What are these two types? One parity is known as even parity. And another parity is known as odd parity. One parity is known as even parity, and another parity is known as odd parity. Okay, when the number of one is even, when the number of one is even and we are using the even parity check, so at that time the value of even parity will be 0. Okay, if we are checking the odd parity, if we are checking it by using odd parity, so in the odd parity case, if the number of one is odd, at that time its value will be 0. Okay, you can understand by using this sentence. Even if the number of one is even, so in parity in even parity case, the bit will be 0. In the odd parity case, if the number of one is 1, so in the parity bit will be the 0. Okay, so this one is the total information about the parity generator circuit. Okay, so this one is the truth table. By using this truth table, you can easily understand what is the mean of parity. You can easily understand what is the mean of parity. Okay, suppose I am considering the message is of 4 bit. I am considering the message is of 4 bit. 4 bit means the message is of D0, D1, D2 and D3. Message is of 4 bit. If the message is of 4 bit, if the message is of 4 bit, so because of this 4 bit, the possible combinations will be the 16, because 2 raised to power 4 will be the possible combinations. Okay, so by using this 4 bit we can generate 16, we can generate 16 different combinations of message. Okay, so accordingly, if we want to add some extra parity bit with this message signal, so we use a parity generator circuit. So parity generator circuit, first parity generator circuit form parity bit, and after making the parity bit, it attach the it attach the parity bit with this message signal. Okay, so attaching the message, after attaching the parity bit with the message signal, the code word will be of 5 bit, because in this 5 bit, 4 bit is of message and one extra bit is of parity bit. Okay, suppose the transmitter use the suppose the transmitter use even parity generator circuit. Suppose the transmitter use the even parity generator circuit. At the time, it find out the number of 1 in the message signal. If the number of 1 in the message signal is in even number, so the parity bit will be 0. If the number of 1 in the message signal is in the odd number, so the parity bit will be the 1. If that, only you can judge it by checking the number of ones, it is in odd condition or it is in even condition. So here in first message, the number of 1 is 0. 0 is an even number. That's why in even parity case, the parity bit will be the 0. In the second message, here the number of 1 is 1, and that is odd. That's why in even parity case, the parity bit will be the 1. Suppose I am considering this message. Here you can see, here the number of 1 will be, here the number of 1 is 3, and 3 is the odd number. And to represent the odd number by using even parity, we use this 1 bit. Okay, you can understand by using this table. And same as in the odd parity case. In odd parity case, if the number of 1 is odd, so it is represented as 0. If the number of 1 is even, so it is represented by 1. It is just opposite to the even parity case. Okay, so we can say that if we find out the even parity, if we find out the even parity, that is, if we find out the even parity, that is, if we find out the even parity, that is 0 1, that is 0 1 0 1 1 0. So after getting the even parity, if we are taking the complement, then we can easily get the odd parity. Okay, if we get the even parity, so by taking the complement, we will directly get the odd parity. So if we want to represent it by using the gate level, so for making this representation into gate level, first we have to find out its boolean expression. So for finding this calculation, for finding this result, we can take the XOR operation of these bits. We can take the XOR operation of message bit, because XOR gate is having a property that if if the number of 1, if the number of 1 is if the number of 1 is if the number of bits, if the number of if the bits are same, so that in the case of XOR gate, the output will be the 0. And if the bits are different, so in the case of XOR, the output is 1. So by using this property, by using this coincidence property, what is the mean of coincidence? Coincidence means the bits are different. Only when the bits are different, so we will get the output in the case of XOR gate. So here, for finding this type of parity bit, we will use this XOR property. Okay, so this above expression, this one, so this above expression represent the output equation to find out the even parity. This even parity is represented by using this PE symbol. Okay, so PE equal to D3 XOR D2 XOR D1 XOR D0, same as P naught, and we know that P naught is nothing but just a complement version of even parity. Okay, so we can easily represent the value of P naught by taking the complement of this PE. So we can say P naught is nothing but a complement of P, and what is the value of P? P equals to D3 XOR D2 XOR D1 XOR D0. So P naught equal to D3 XOR D2 equal to D1 XOR D0, and at last we can take its complement for finding the value of odd parity. Okay, so how can we make its gate level structure? This one is the this one is the its this one is the gate level, this one is the gate level structure, this one is the gate level structure of parity generator circuit. This one is the gate level structure of parity generator circuit. Here you can see that here we consider some XOR gate. Here we can take here we have considered some XOR gate for finding the even parity, because even parity PE is the XORing operation of all bits. That's why we have considered the XOR gate. Okay, we can also make this similar operation. We can also make this similar operation by taking some other bit. Okay, because by using NOR and by using NOR and NAND gate, we can make in any type of gate. That's why NAND gate and NOR gate are known as universal gate. So we can implement this XOR gate by using any type of gate, by any type of implementation according to designer requirement. Okay, this one is the okay, so this one is the representation of even parity generator, and this one is the this one is the gate level representation to generate the odd parity generator or generation of odd parity generator circuit. This one is the representation of odd parity generator circuit. Okay, here you can see by expression it is clear that if we are taking the complement of even parity, then we will get the odd parity. Okay, so this similar concept is applied in this gate level design also. If we are taking if we take the complement of the output, if we take the complement of output, then we will get the odd parity. So for taking the complement of this output, we will take a NOT gate here. We will consider a NOT gate here. This NOT gate provide the complement of this PE, and we will get the odd parity in the output side. Okay, so this one is all about, the theoretical portion. So this one is all about the theoretical portion of parity generator. Okay, you can note down the theoretical portion. You can note down the theoretical portion that is mentioned here. You can note down this theoretical portion that is mentioned here. And in your textbook, Neil Wested, the theoretical representation is given as this one is the equation, this one is the equation, this one is the equation of parity generator, this one is the equation of parity generator. Parity equals to a naught XOR a1 XOR a2 XOR a3, and so on. Okay, this parity generator can be of 16 bit, can be of 32 bits, according to requirement, according to the length of bit stream. Okay, so this one is the theoretical portion that is represented in your textbook, and the diagram and the circuit diagram or the gate level structure for this parity generator is represented here. Circuit level representation is represented here. This one is the gate level structure. This one is the gate level structure. This one is the gate level design. This one is the gate level design of a parity generator circuit. And the second representation is also a parity generator circuit, but it is in some other logic. This logic is known as dynamic version. This logic is known as dynamic version. This logic is known as dynamic version of XOR gate. This logic is known as dynamic version of XOR gate. Here each XOR gate, here all XOR gate are here all XOR gate is mentioned by using, here all XOR gates are mentioned by using these similar this fashion. The one combination, this simple combination here, this simple combination is make a XOR gate. So here this combination is make a XOR gate. Okay, this combination is make some another XOR gate. This combination is make some another and XOR gate. Okay, so this overall expression is responsible responsible to find out A XOR B XOR A XOR B XOR C XOR D. C XOR D. Okay, so this dynamic representation, is responsible to get this 4 input. I think it is clear to all of you. I think this topic is clear to all of you. Okay, now if you want to make a static input structure, this one, diagram is also a representation of A XOR B XOR C XOR D. This one is the also a representation of A XOR B XOR C XOR D. This diagram, this representation is known as static 4 input XOR gate. This diagram is also known as static 4 input XOR gate. Okay, static 4 input XOR gate. How we can get this diagram? We already know that what is the expansion, of A XOR B, what is the expansion of A XOR B. If we expand this A XOR B, A B bar, A XOR B means A B bar plus A bar B, A B bar plus A bar B. A XOR B means A XOR B plus A XOR B plus AB XOR. Same as C XOR D means C XOR D plus CD XOR. And at last, when we take the XOR of this and the XOR of C XOR D, then we will get a boolean, we will get some SOP form equation, we will get some different terms, and these different terms we will get we will get when we expand this simple static circuit. Okay, this one is all about the representation of parity generator circuit. So I hope you all understand this topic of parity generator. So thank you so much. In next lecture, uh, we will study some other topic. So we can take 0 1 detector or comparator topic in our next lecture. Okay, thank you so much.